HashMap. Alright, so let's go ahead and discuss one of my best favorite data structures. This is a powerful data structure that we use, for example, on spell checkers, also on dictionaries. Another example could be that compilers use to quickly find addresses of variables on memory. It's used also on code editors. In summary, every time you need to find an item super fast, a HashMap is going to be the best tool for you. So how it works? Basically, you can imagine a HashMap as key value pairs. In this lecture, I'm going to use kind of a tuples in order to explain some example. For example, key value pairs like this, where the key is going to be a unique value, and the value could be an object or any data representation that we need to store, like for example, string, an integer, or anything like that. The most important point is that the key is going to be passed as parameter into a hash function in order to return a memory address related to the position of the key, in order to know where we are going to store the value. So for the hash function, the most important point is that it should be deterministic, which means that every time we pass the same input is going to return the same value. So I'm going to show you a few examples of how we can do this kind of hash functions. So basically we can use the hash function in order to store and retrieve values, because we are going to have the same result every time. So you might already thinking where we are going to store all these values. So basically the hash table should map the key into an index value. And yeah, as you might already think, basically we are going to store the values in arrays, or in this case list in Python. So let's say, for example, if the key is a string, we can transform the key into an integer, and then we can apply the modulo function. So don't worry much about this, because I'm going to show you how we can implement these hash functions in a few minutes. So let me go ahead and drag a small example here to understand how this works. So as I mentioned before, we are going to use list in Python in order to store the values of the hash match. So let's imagine that we have a list with 5 positions, and for simplicity, each index in our list is initialized with none or null. So let's go ahead now and imagine we are inserting some key value pairs into our HashMap. So remember, we are going to insert in a specific key any value that we want, like for example an object, a string, an integer, any kind of data that we need to store related to the key. The key is usually a unique number identifier. So like for example, if you are storing information about a person, like for example the age, the social security number, first name, last name, so far and so on, probably the best key in order to store this information is going to be the social security number, because it's a unique number, rather than, for example, using the first name or the last name, because chances are that a lot of people is having the same first name or the last name. The most common data types for keys are numbers or string. So for simplicity, let me just go ahead and use numbers in this example in order to calculate easily the module of the number to calculate the index where we are going to store the values. We will discuss later what happens if we use string as a key, how we can transform into a number, and from there we can use the module function in order to create our hash function. So let's go ahead and imagine that we are inserting in the key number 6, we are inserting a string with the letter B. So as I mentioned before, we are going to use a hash function where we are going to pass the key as a parameter, and it's going to return the index where we are going to store the value. So basically what we need to do here is basically create an hash function that is going to return the index of the value. So the most simple function that we can take is just taking the module of the key, which is just basically something like this. It's going to be the size of the list that we are using. So in this case, we are using a list with 5 elements or 5 items. So basically the only thing that we need to pass here is 5. So let's go ahead and calculate this hash function very quickly in our terminal here. So basically let me log in Python 3, and then we can use the same formula as here. In this case, 6 modules 5 is going to return 1. That means that we need to use the index 1 of our list in order to store the value that we want to store. We are using the 6 in the hash function, and then we are storing B in the position number 1. So in this case, we remove none and we insert bit. So let's go ahead and add another example here. where we are going to take as a key the number 3 and we want to insert C. Here is we use 3 as a key and we run this small script, it's going to return 3. So the index number 3 is going to be basically here. We need to insert the letter C. Let me add quotation marks just to make sure that we are inserting a string in our list. Alright, so let me add another example here. The key is going to be 11 and we need to insert the letter D, for example. So as we run this small example here, 11 module 5 is going to return 1. So hold on a second, what happened here? The index number 1 is already in use, so here is where we are going to have a collision. There is several ways to solve the collision problem. One of them is using a chaining algorithm, and the other one is using an open addressing algorithm. An open addressing by itself has several methods in order to solve these problems. Like for example, the linear problem is going to do is basically check the next slot. In this case is going to be index number 2 and it's going to insert the letter D there. However, it can easily create clusters, which means that it's going to be every time harder and harder to find a next slot empty. Until some point the list is going to be full, so we have a big disadvantage of using this kind of algorithms in order to solve a collision problem. So I leave to you to research the other two open addressing algorithms in the case that probably they are asking in your coding interviews. So in this lecture we are going to use the chaining approach in order to solve the collision problem, which is just basically store a linked list on each position of our list. So let me just quickly roll back toward the problem that we previously had before, which is just basically store the B here at the beginning, the B here in the index number 1 and the letter C in the index number 3. So when we use the key 11, we result in an index position as 1, which is just basically we are going to use a linked list. So as we already have a linked list in index number 1, the next thing that we are going to use is just basically adding another item in our linked list, which is going to be G. However, in this case, what we're going to use is just store as a value, which is basically an entry. In this case, we are going to store the two things, the key and the value, and same for the other keys. Similar to what we have in index number 3, which basically is just going to store the key and the value related to that index. Alright, so enough theory for now, so let's go ahead and implement a HashMap class that implement all these functionalities. Alright, so quick note before we get started is that I renamed the linked list module into a snake case. This is because this is a convention in the Python community. However, the class name is the same as before. And I also added this small line here before we added our test cases. What this line basically does is that when you import a module from another module, it's going to exclude all this line of code from here, because when you export a module from another module in Python, the code is going to be kind of executed behind scenes. So basically it's not going to run the test when you import the module. So just something to keep in mind, we are adding this to have the test cases in the same class just for simplicity. However, it's a very good convention, obviously, having the test cases in a separate unit test class. Just for simplicity, we are going to add the test case in the same module. Okay, so going back to business, the first thing that I'm going to do is just import our linked list class from our linked list module. And then let's go ahead and create our HashMap class. First, I'm going to create an entry class in order to store the key and the value that I mentioned before here. This is because in our linked list, we are going to store an object instead of using a value. So we can pass an object with the property key and a property value in order to have reference when we need it. So an entry is going to be basically the value of our linked list. Let's go ahead and create our init function for the HashMap class, which is just going to initialize our entries list, where we can also set an fixed size. Just for simplicity, let's set as 5. And then basically we need to create our init function here. Let's call our list entries and let me initialize in none. Alright, so the most basic function in a HashMap are going to be the get, and we need to pass only the key. And the next one, we need a put function. In this case, we need to pass a key. and the value. So let's get started with the get method here. So let's go ahead and define a get method, and we need to pass only the key value. All right, so in order to get the value of a key, we basically just need to return the entry from the linked list. All right, so let's go ahead and create a variable here. So we can say something like self.getEntry, and we pass the key value. So let's go ahead and implement the getEntry private method in order to retrieve the entry from the linked list, and the linked list is going to be in the index position from the key value. So let's go ahead and implement this private function here. Let's call it like this, and we need to pass the key value here. Here in our linked list, we are going to have a list where on each index we are going to have a linked list. Alright, so the first thing that we need to do before we are going to get our entry is obviously getting the linked list related to the index position. So we can call another function here. So we can create a variable called linked list. Is going to be equal to another private method in order to get the linked list, and we need to pass again our key function. So we can define another function to get the linked list, and in this case we need to pass key. Okay, so in this case we need to return the linked list that is related to the index from this key, and the linked lists are going to be stored in our self entries variable that we define here at the beginning. This variable is going to be initialized with none values in the 5 positions. So if there is no entry, it's going to return none. So we need to return the value that is going to be stored in the index position. So in this case, we need to return the value that is related to the key. And as we discussed before, this is going to be a deterministic function that is going to transform the key into a number where we can do basically the module or the hash function here. So the only thing that we need to do here is just basically transforming the key into a hash function. So we can call it self.getHash, and basically we need to pass the key. And once we got the index from this function, we are going to return either none or either the linked list related to that position. So let's go ahead and implement this function. And here for simplicity, let's validate that the key is going to be either an integer or a string. So if it's an integer, it's very easy. We don't need to do anything because from an integer, we can already calculate the module very easily. However, what happens is there is a string, like for example, something like this. So we need to transform this into an integer that is going to be deterministic. We need to have always the same value from this string into this one. Like we can use the OR function, and this function is going to return the Unicode code specifically for that character. All right, so we are going to have always the same values related to the same string, so that way it's going to be deterministic. So we can sum all the Unicode values from that string, and then we can calculate the module from that number. So let's go ahead and implement that functionality really quickly here. So first I'm going to initialize the hash to the key, just in case this is a number. Let's go ahead and validate if there is a string, so we can use the instance function where we can pass a value, and then we can compare if this is a string. So if this is a string, we need to initialize our hash function to 0, and then basically what we're going to do is just looping through each character of the string and just transforming with the OR, getting the Unicode value and just storing that into the hash function so we can use it later. So here we are going to have R with the same number for the same string, so we can finally just return our hash function that is going to be basically the hash module from the size of our list. In this case, we can use our size constant that I created before. Alright, so we have our deterministic hash function, so it's going to return the index in this case, and from the index we can return the value that we store in our entries variable here, that it could be either case unknown or it could be also a linked list. Finally, we just need to return entry value, obviously if there is an entry, otherwise we can just return none. And the get linked list is going to be called here, so we are going to have our linked list in this scenario here. So the first thing that we need to check is there is a linked list. We need to keep in mind that we are going to receive the head of the linked list, so we need to search for all the values inside our linked list and check for the key that we are getting as parameter. It's just basically going through our linked list, checking key values and use stop when we find the value that we are looking for. So let's go ahead and implement this functionality here, which is just very similar to what we did in the print method on our linked list, that is just looping through the element. However, we are going to add an if statement to stop wherever we find the key value, all right? Here we can check is current that value, that key is going to be equal to key that we are receiving by parameter here. In this scenario, we can return current that value. Otherwise, we need to continue looping, right? So in this case, we can say current that nets. Use quick requires. Remember, we have available in our linked list the first now. So basically, we are going to start in the head of our linked list. We check if there is a linked list available. In this scenario, the value related to our linked list is going to be this entry class. And then we got the entry class. We need to check for the key. If the key is equal to the key that we are trying to get, we can return that entry value from there. And in this case, the value is going to be an entry object that we just created here. Otherwise, we will return none here because we were not able to find the entry related to this key. In this scenario, we got the entry, but there is a chance that it could be also none. So we can say something return entry that value. If there is an entry, otherwise we can return none. And that's pretty much all the code related to the get functionality here. So we can minimize our private function and we can go ahead and implement our put method. So in this case, put is going to receive two parameters here. It's going to be the key and the value. So we need to check first if the key already exists in our HashMap. If so, we only need to update the value of the object. So that is going to be the most easy case. In this case, we can do something like self.get entry. We pass the key and then we check if there is an entry. We can do something like entry.value is equal to the value. So basically, we are going to override the value. Otherwise, if there is no entry, that doesn't mean that that specific position in our linked list already have or a linked list. So we need to check there is already a linked list and we need to add the new value at the end of the linked list. Otherwise, we need to create a new linked list and just add the value as the first value of the linked list. All right. So let's just go ahead and create a method that can be called something like. So in this case, we can pass the key and then we can imagine like this method is going to return the linked list. So we can use our function add first to add this at the beginning of the list. So we can use add first, and here, very important, we need to pass as entry object. So let me quickly wrap up this in a new line. So it's going to be basically something like this. When we do the put method, we usually don't return anything. Let me create it here. All right, so what we need to do in this function is basically return the index from this key, check if there is already a linked list and return it. If not, we need to create a new one. So let's go ahead and create a variable index. So we can call something like cells.get hash. In this case, remember the get hash is going to return the index for a specific key in a deterministic way. So it's always going to return the same. So once we have the index, we need to check if there is not self entries in the position index. Basically, we are going to create a new linked list, as simple as that. So we can do something like linked list that we imported previously. And basically at the end, what we need to return is the linked list itself. So that's it. We got the index from the key and then we check if there is not linked list related to this index yet. So we just added one and just basically return the linked list related to that index. So just to do a quick recap of the functionality, in this case, we are getting the entry and checking if the entry exists. We are updating the value of that entry specifically, and we don't need to return anything else. So in this case, we can return the functionality here because we are only updating the value it already exists. However, if the key doesn't exist, we are just getting the linked list related to that key position and adding the value to the head of the list. Alright, so I think we are ready to test this HashMap class, so let me just go ahead and add the test cases at the end of this module. So remember, what this line of code does is just basically avoiding executing the line of code inside the if statement when we import this module from another module. So basically the line of code that we put here are not going to be executed when we import this module from another module in Python. So the first thing that I'm going to do is just create a HashMap object. As on our nested, is just using our put method. And let me insert a name. In this case, let's call it name, and let's use my name here. Let me just go ahead and add our first assert, and we can pass name, and here the result should be equal to Andre. Awesome. So a second test that we can do is just overriding or updating the current key for the name. So in this case, let's use again the same key, name, and let me use updating this to, for example, Jos. So if we use this same assert, the result here should be Jos, because we are updating the same key. Another assert that we can add is accessing to a key that doesn't exist, like for example, not used. We haven't added anything to our HashMap using this key, so in this case, the result should be none in this scenario. So our ID is just worrying about this comparison here, so we can do something like this, for example. So let's go ahead now and test the collisions. So if we use something like HashMap put, let's use number just for simplicity, is we use the number seeds, and then we pass in something like, for example, 1, and then we use 11 and we pass the number 2, for example, and then again we can start adding some validations to our collision. The first thing that we could expect is that if we get the key 6, it should return number 1. Similarly for the 11, it should return 2. So basically we are just validating that the chaining is working, and also obviously that we are not updating the value from seeds. And also we already tested that our keys for string are also working in this scenario, and also the keys using integer numbers is also working. So let me just go ahead and quickly run our test. Here we don't get any errors, so that means that everything is working as expected. So basically this is how we can create a HashMap from scratch using simply lists and linked lists. Alright, so let's go ahead and just quickly discuss the time complexity for this function here. Remember that I told you that the time complexity for the get is going to be BO1. This is basically because we are accessing to the items inside the list via their index. So this is BO1. However, you might already think that inside the get entry we are using a hash function, and for strings we are looping through each character. So you don't need to worry about the hash function that we are using. The publicly available libraries that we are going to see in a few seconds, the dictionary inside Python, has been passed for dozens and thousands of tests, because they are obviously using a most optimized hash function where, for example, they only take a few elements from the string and so far and so on. And obviously in this case we are using a large array and not obviously a fixed size like this one. So the final consecutive time complexity for a HashMap is going to be BO1 or constant time. That's why this data structure is very important for search algorithms where we need to look up for any elements. Similarly, the time complexity for the put method is going to be BO1 again. This is going to be constant time. Basically here we are also using the get entry method that is basically using the hash function. However, we also dealing with collisions in this method. And again, for example, for chaining, open addressing, etc. After several tests on these algorithms, the concession is that for most of the time, the put method in a HashMap is going to behave in BO1 or constant time. Not all the time, but for most of the time. There is a lot of very interesting lectures, investigation, and so far and so on related to the time complexity in HashMap, so feel free to read that through the internet. So the only thing that you need to take note is that HashMaps behave in time complexity BO1 or constant time, either for get, put, or remove. Alright, so now that you already know how to create a HashMap or a hash table from scratch, let's go ahead and see how we can implement this functionality in Python. So let me just go ahead and create a new file. Let me call it HashMap examples. In Python, we can use the built-in function called dictionary. This function receives a keywords argument, which means we can pass valid keys. Like for example, the name of an employee is going to be equal to the unique identifier. And using commas, we can add more items to our HashMap. So in this case, let's call this Ava, Joe. So if we print this variable here, This is going to be the format of a dictionary or HashMap in Python. It's very similar to JSON objects. So we have the keys and the values, and each item is going to be separated by a comma. Remember I told you that it's very useful to have the keys as an unique identifiers. In this example, having the key from an employee's representation with the name is not very useful because chances are there is more people with the same name. In this case, I think it's very good to use the unique identifier as the key. However, you can define the dictionary as empty and start adding the values from here. Using square brackets, we can add the key, and then we just basically can pass, for example, the name, and in this case it should be date, and so far so on. In this case, let me add the second one, let me add the third one. It's going to be Ava and Joe. So if I print this variable again, you might see that now we have the key with the unique identifier. Another popular way to create a dictionary is just using the curly braces. So let's just go ahead and copy the outputs here and just reuse it here. This is another valid way to create dictionaries using curly braces. Key value pairs are going to be separated by a colon, and we can continue using commas to add more items to our HashMap. So if I print this again, you might notice that we have the same result as before. And this is a very human readable format because it's pretty similar to JSON objects. We can have also nested dictionaries. So let's imagine now that the value from each key is going to be a dictionary representation of an employee. So let me add another curly braces here. In this case, we can repeat information from the key. So for example, the ID is going to be again 001. So let me add more information here very quickly. And for example, as a second parameter, we can add the salary, something like this. And probably we can also store the role. So in this case, let's say it's a Python developer. Great, so let's just go ahead and duplicate this information for the Ava user. And let's say Ava is a Java developer. Be careful here, remember the keys need to be unique. So if we print this object, you might see that we have now a nested dictionary inside our keys. Alright, so let's go ahead now and see what are the most important methods available. And the first one is the contains method. Remember I told you that HashMap are designed for search. Wherever you need to search very fast, HashMap is going to be your best tool. And we are going to use this a lot during our coding interviews, basically because searching in HashMap is going to be BOS one constant time. So this method is very important. Whatever we need to check is an item is inside our HashMap. So the first way to check if we have a key in our HashMap is using the get method available. So now we can use our employees variable and we can use the get method. Here the first parameter is a key. In this case, let's pass 001. Remember, it's going to be the first key that we have available here in our variable, and this is going to return a new HashMap, or it's going to return none if that key doesn't exist in our HashMap. All right, so let's just go ahead and print this value from here and see what we got. Awesome, so we are getting basically the new object related to the ID 001, and in this case it's going to be this new dictionary from here. However, what happened is we access to an item that doesn't exist. Let me run this again. We are going to receive none or null. So let's imagine that we need to print something like this, salary, and if we run this code again, we are going to get a non-time error, which means that the salary key is not available in our HashMap. So the most common thing to do here is just basically adding an if statement and checking as there is an employee or it's different than none, so we can fix this error just like that. So if we pass, for example, the ID 002 and we run this code again, we are going to have the salary related to the number 2 key, which is going to be basically 3000. All right, there is another way to check the contains function. So in this case, let me just call it number 2. So we can use the in keyword in order to check if there is a key inside our HashMap. So in this case, we can use something like this. If 001, for example, is in employees, that means that we can print anything related to this key. So in this case, we need to take employees position 001, and then we can print, for example, salary. And if we run this code again, we are printing the salary related to the employee ID 001. And please notice that we are using square brackets in order to access to the information related to our keys. And this is basically because the first key is going to return another dictionary, so I can use again the square braces in order to access to any key inside our employee information that is going to be any of these 4 keys. Over here we are assuming that the salary key is going to be available to access. If not, we might need to add another is statement that saying that, for example, that salary is going to be available for us. So we can do, for example, something like this. So in this case, for example, we access to something that doesn't exist, like for example something like this. We are not going to get any error because we are obviously adding this validation from here. Obviously here we are assuming that salary is going to be available in the second dictionary that is going to be returned here. However, if you are not sure that this is going to be available, it's always recommended to add a validation like this before accessing to any key that you are not 100% sure that is going to be available. That's why you can use the get method or the square braces method in order to access to elements. However, the get method is going to give off an opportunity to return none if we don't find the item in our dictionary. So let me show you. So we can use something like, for example, employee is going to be equal to employees that get, and let's say we are trying to access to something that doesn't exist. However, you can pass as a second parameter the default value is the item is not found in our HashMap. So we can pass something like none, and we are not going to get the error that I showed you before. So let me show you, and let me run this code very quickly. We are not getting any error, so we are just returning none in this scenario. Alright, so let's go ahead and discuss how we can add items to our dictionaries or use the put method that we designed previously. Adding or updating keys obviously in your HashMap or dictionary. So in this case, let's say that we want to add another employee. Let's call it 003, and in this case we want to insert also another dictionary, and let's just go ahead and copy something very similar that we already have in our previous employee. So it's start adding everything like this. And we can rename, so we can update our ID here, the name, a new salary here, and maybe another role here. So let's go ahead and just print our employees variable here. We are adding a new item to our employees dictionary. Something really important about dictionary is that if, for example, you use an existing key and you update it with a different value, like for example a string, that value is going to replace your previous values. Alright, so be careful when you are updating existing keys in your dictionaries. And again, we can use nested square brackets in order, for example, to access to another property inside a nested dictionary. So we can update, for example, the salary for the employee number 3. So this is going to be our new salary. Another option to update or add values to our dictionary is using the update function available. So in this case, obviously we need to pass a keyword argument. In this case, we can pass another dictionary. So in this case, let's say, for example, for the employee 001, I want to update only the salary information to be, for example, 1000. So if I run this algorithm again, so you might see that the salary is updated only for this key. However, what happens is you pass a key that doesn't exist. Here is a run again, this item is going to be added also. So the main point is basically this method is called update, but it's also going to add if the item doesn't exist in your dictionary. Another way to update values to your dictionary is passing a list of tuples. So, and as you can see here, if I run this value from here, the salary is going to be updated to 900. So remember, you need to pass a list of key value pairs represented as tuples. I personally, during my coding interviews, I always use the square brackets approach. However, feel free to use the method that you feel more comfortable. Alright, so we have learned how to update and add items to our dictionary. So let's go ahead now and see how we can remove items. Let me copy this print method from here and let me add it here to the end. Alright, so up to now we have 3 employees. So let's go ahead and remove the employee with ID 003. We have 2 options. The first one is using the deal keyword, and then we need to access to the specific key using a square brackets. So in this case, let's say we want to remove the 003. So if I run this code again, you might see that the key 003 was removed from our dictionary. And the second way to do this is basically using the pop method available in our employees dictionary. So we can use pop and pass in the key that we want to remove. So in this case, it's going to be 003. If we run this code again, you might see also that the 003 key was removed. What happens is we trying to remove a key that doesn't exist. So if we run this code again, you might see that there is a key error because the key doesn't exist. So let me check if that error happened saying we're using the delete keyword. So let me just try this bit here. Yeah, we got the same error also for the other method. So it's a very good approach validating if the key exists before removing. Remember, 004 is in employees. We can try to remove that item from our dictionary. All right, so in this case, if I run this code again, I'm not going to get any error because this line of code is not going to be executed because 004 is not available in our dictionary. All right, so another action that we are going to do a lot in our coding interview is looping or iterating over a dictionary. So a dictionary is an iterable in Python, so we can use for loops in order to iterate over our dictionaries. So the most common way to iterate over a dictionary is using a for loop. So in this case, we can use something like key value, and we need to use the items function available in our dictionary. So we can do something like employees.items. This is going to return basically an iterable. On each iteration, we are going to receive the key and also the value. So I think in this scenario, we can rename this as an ID because it's going to be the key that we are working here. I added an underscore because this is a reserved word in Python. And here we can have something like employee. So we can print, for example, what we got here, in this case, ID and employee. So let me run this script again. We are printing the ID and obviously the dictionary related to that. If you are not interested in getting the keys, so in this case you can use values and it's not going to return any ID in this case. So you are not only going to have access to the values from your dictionary. So if I run this again, we are printing only the values here. All right, so before we finish our dictionaries or hash table in Python, let me just go ahead and discuss how we can create dictionary comprehensions in Python. Early in the course, we discussed a formula to use list comprehensions. If you remember, we use square brackets referring to lists, and in this case, we are going to have an expression followed by a for item in items. Similarly, for dictionaries, instead of using square brackets, we are going to use curly braces, and that's pretty much that's it. So let me show you a small example. So it's very common that in your coding interviews, your inputs are going to be lists. So let's imagine that we have an input like this, a list of lists. So the first position, the name, and the second position is going to be related, for example, to the salary. Let me add another item here. So let's imagine we have Ava with another salary here. We might need to transform a list into a dictionary because chances are that we need to have a data structure for fast search. So a dictionary is a perfect solution for this kind of scenario. So let's say we want to transform this into a dictionary where the key is going to be the name and the salary is going to be a value. So let's just quickly do a comprehension here. And we can start using our formula. We need to use curly braces here and we need to use expression for item in items. So obviously here the items is going to be the input. The item is going to be an employee information. The expression here is going to be separated by a colon where we need to define the key and the value. All right. For the key, it's going to be our employee variable in the position 0 because we are going to take the name as our key. And similarly, we need to have an employee in the position 1 that is going to be the salary. So if we print this variable from here, we are going to have a new dictionary available for us to use. So we can search anything in this dictionary by the names, and we are going to retrieve the salaries in BOS1 or constant time. And we have covered most of the cases that we are going to use in our coding interviews.